So in chapter 7.2, we're actually going to calculate probabilities using the z-score transformation. So our objectives is to convert the values from a normal distribution to z-scores, and then using the z-scores, we're going to find areas for problems under the normal curve. And then, given a value from a normal distribution, using a z-score, we're going to find the corresponding proportion and then find the value for x. Objective 1. Convert values from a normal distribution to z-scores. So our goal is to go from a population that has an actual mean and standard deviation to the standard normal curve up here to find probabilities. So that you will recall that a z-score of data values represents the number of standard deviations that a data value is above or below the mean. If x is a value from a normal distribution with mean mu and a standard deviation sigma, we can convert x to a z-score by using the formula below. The z-score formula is right here, and we've talked about it a number of times. So in this particular example, we have a population of females, and the mean value in this population appears to be 64. So here is our mean. This is x bar, or mu actually. And sigma in this particular case is 3. And so now we want to find a z-score value of a lady whose height is 67 inches. So x is 67 inches in this normal population. And we're going to use the z-score. So we're transforming from an x variable to a z variable using the z transformation. Here it is. And we see when we do the calculation, 67 minus 64 divided by 3, we get the value at 1. The z value is 1 in this particular case. So we transformed 67 to 1 under the standard normal. So now we're going to find areas under the normal curve using our tables that we have looked at before. So always when we're using tables to compute areas, we first need to use or create a z-score value before we can use the table to find areas or probabilities. So here's our first example. A study reported that the length of pregnancy from conception to birth is approximately normally distributed with a mean value of 272 days and a standard deviation of 9 days. We want to know what's the probability of a pregnancy lasting longer than 280 days. So we see I have a problem here. It should be the probability that x is greater than 280, right? So x is our variable of interest, right? It's telling us the days of a pregnancy. And so our z-score value for 280 is our calculation, right? And we get 0.8 0.89 as my z-score value. So now we're going to go to the table. We're going to use table A2, and we find the area to the left of z equals 0.89. So that area on this side over here is 0.8133. But we want to find the probability that x is greater than 280. So we want to find the area here. So to find that area, we have to do what? Well, we have to take 1 minus this area is going to be the area over there. And so this area ends up being 0.1867. So now we can say the probability that x is greater than 280 is approximately 0.1867 or 18.67%. Well, we're going to continue the same problem, but now we're asking the question, a pregnancy is considered full term if it lasts between 252 days and 298 days. And now we're asking, what is the proportion or probability of pregnancies that are full term? Well, here's our probability statement, right? And so this essentially, we're going to rewrite it this way: the probability that x is less than 298 minus the probability that x is less than 252, right? So these are equal statements because why? We're going to be subtracting areas again. So we find the z-score of the 252, and when we do that, we get a z-score of negative 2.22. Then we're going to find the z-score for 298, and we get a z-score of 2.89. And so now you can see on our chart, right, we have here's our values of x, but now we have the corresponding z values. Now, because we have the z values, we can go to our standard normal curve table, which is in A2, and we can find the area to the left of 2.89, which is 0.9981. And the area to the left of negative 2.22 is nothing more than 0.0132. Now, since we want to find the probabilities between those two z values under the table, we subtract the areas of the larger area from the smaller area, and we see that we get 0.9849. So we now can rewrite this as the probability that x, or actually 252 less than x less than 289, or 298, I'm sorry, is approximately equal to 0.9849 or 98.5%. Okay? So now we're going to do the same problem using our graphic calculator, the TI-83 or 84. So in this problem, it's the same problem as before. We want to find the probability that the probability that pregnancies last more than 280 days, right? So there's our probability statement. And now we can use the normal CDF command under second vars. So we have to hit the second vars key, right? There's the second key, and then we hit the vars key. And then we select the normal CDF option. When we do that, we notice that in our distribution, our probability distribution for x, 280 was here, and we're looking for this area here. So our lower bound is 280. So we have to put 280 in. We hit a comma. And then our upper bound, since we don't really have one, right, there's none that's been chosen, we do the default of 1E99, comma, then we put the mean value in and the standard deviation in. We put parentheses closed, and we hit enter. And then that value there is our probability. So again, our probability that x is greater than 280 is approximately 0.187 or 18.7%. Okay, this is a little bit more accurate because there's a formula that's involved to find these probabilities. So again, we can use the TI-83 or 84 to find the second problem that we did by hand, the probability statement that what is the probability that pregnancies are at full term. So we can use the normal CDF command again using second vars. The lower bound is 252. The upper bound is 298. The mean again is 272, and 9 is the standard deviation. So you can see the numbers that we're putting into the calculator. We hit enter, and we find the probability of our statement. So again, the probability that 252 is less than x less than 298 is approximately 0.985, and this means or 98.5%, right? So now we're going to find a value from the normal distribution corresponding to a given proportion. So we're trying to find x. So our idea here is what we're trying to do is find a value of x for an area or a probability. Okay, so we want to find x. So suppose we want to find a value from a normal distribution that has a given z-score. To do this, we solve the standardization formula z for x. Okay, and we're going to do that here. So when we solve this, we have z is equal to x minus mu over sigma. We multiply both sides of the equation by sigma. We get z sigma is equal to x minus mu. And now we solve for x, so we're going to add mu to both sides. So we get mu plus z sigma is equal to x, right? So that's our algebra lesson for today. And that gives us the value of x that corresponds to a given z-score value is that formula. So for example, the height in a group of men are normally distributed with a mean mu of 69 inches and a standard deviation of 3 inches. Find the heights whose z-score is 0.6. Interpret the results. So we want to find the height with a z-score of 0.6. Therefore, when we put it into the formula that we just calculated, we get 69 plus 0.6 times 3, and we get 70.8 inches. So our interpretation is that a man at 70.8 inches tall has 0.6 standard deviations above the mean under the standard normal curve. So our idea here is the steps for finding the normal values given a particular z-score value. We sketch the normal curve, label the mean, and the value x to be found in the and shade the in and label the given area. So for example, if I have the normal curve, right, and I want to find x, the question is do I want to find the area to the left or to the right? And for a particular z value, there is a corresponding x value. So I find the z value, and then I put it into our formula to find x, right? And then we can find where the area is in relationship to x. If x, right, if x is on the right-hand side, right, we were going to subtract 1 from the area that we get on the left to find the area on the right. So in looking at the body of a table, the area closest to a given area to find the z-score corresponding to the area. So if we're given an area, we have to find the area closest to the given area, and then find the z-score corresponding to that area. And then guess what? We put the z value into the formula to find x. So here's our example. A Mensa is an organization whose membership is limited to people whose IQ is in the top 2% of a population. Assume that the scores on an IQ test are normally distributed with a mean of 100 and a standard deviation of 15. What is the minimum score needed to qualify for membership in Mensa? So in this particular case, we're going to write the following statement. I want to know what x is, so I'm going to call it A, right, given that the area is 0.98. And why 0.98? Well, the figure shows that the value of x separating the upper 2% from the lower 98%. So our table that we're going to use always shows information to the left of x. And we're trying to find a value for x. So to get the 9.98, we have to subtract 1 from 0.02. Then we look for the area closest to 0.98 in the table, and we find it to be approximately 0.9798, which corresponds to a z-score value of 2.05. So once we find inside the table the probability, we then need a z-score to find x. Once we have the z-score, we can go to step 4 and we plug it into our formula that we had developed to find x, and we see that in this case 100 plus 2.05 times 15 is equal to 130.75, And of course, IQ scores are generally whole numbers, so we round it to x is approximately equal to 131. So now we're going to do the same problem using the TI-83 or 84. So in the same problem, the Mensa problem, what is the minimum score needed to qualify for membership in Mensa? Again, we have to calculate the area to the left of x. So we have to calculate this area in the same way we did before. Once we have that area, we use the second vars command. So we have to go second vars, and we locate the invert norm command. And once we have the invert norm command, the first entry is 0.98. That's the area to the left of x. Then we select 100 because that's the mean value, and the standard deviation is 15. When we hit enter, we get x to be approximately 130.80, right? And again, since IQ scores are generally whole numbers, we round up. Now we don't always round up if the value of x is on a continuum. So in this chapter, you should know how to convert values from a normal distribution to z-scores using the z-score transformation. You need to know how to find areas under a normal curve, either using it through a table or using the normal CDF function on the TI-83 or 84. And finally, you should be able to find a value x on a normal population corresponding to a given proportion or probability. So that concludes section 7.2. And we'll eventually get to 7.3, which is sampling distribution, but we'll be taking a break from this before we get to that.